Hello, I hope people who went on the ski trip today had a wonderful time. I know that we were being very productive here back in school, having a good time. We missed you all, but we had a good day anyway. So we're looking at things from yesterday, talking about what's going to preserve or reverse an inequality, seeing if we can figure out some properties of inequalities that would help us solve. So first, we just need to have a little lingo around this. If you are preserving something, you are keeping it. So that means it would stay the same. If you are reversing something, think reverse, reverse. You're going to be flipping it. It's going to be switching around. Okay? So we looked at this inequality 5 is less than 10, which everybody agreed is true. And we examined what happened when you did different operators upon it. So basically, when you did different things to this inequality, did it stay, that symbol, did it stay the same? Or did the inequality actually reverse or flip? We're using this because students started to notice some things on Tuesday, and we wanted to see if we could generalize this more broadly. So if we started with adding 5 to both sides of this inequality, it's a lot like a balance or an equation in that you can do something to one side as long as you do it to the other, and that's going to keep the inequality as balanced as it was before. So if I add 5 to both sides, I'm now going to have that 10 is related to 15 somehow. 10 is less than 15. So that tells me that the inequality was preserved. It stayed the same. It was less than before, and it is still less than. If I add negative 5 to both sides, 5 plus negative 5, additive inverses. We had 0. 10 plus negative 5 is 5. 0 is less than 5, so I compare to the original. It is still preserved. It is the same. Minus 5, well, that's just like this. 5 minus 5 is 0. 10 minus 5 is 5. 0 is still less than 5, which means that the sign has once again remained preserved. And then minus negative 5. Well, we can remind ourselves that subtracting a negative is the same as adding a positive. So in fact, this is the same as plus 5, which we already did up here. And we know that 10 is less than 15, and so that preserved the inequality. So it looks like for all of these things, the inequality is going to stay the same. If you add or subtract to both sides, you're going to keep the inequality symbol from flipping. It's going to preserve the inequality. What if you start multiplying? If I do 5 times 5, I'm going to have 25, and if I do 10 times 5, I'm going to have 50. Is 25 less than 50? Yes. So that inequality remains preserved. If I do it by negative 5, multiplication by negative 5, now I would have negative 25 compared to negative 50. Now I need to start thinking, okay, the farther to the left you are or down you are on the number line, the more negative you are, that's actually the least number. Okay, so as you go left or down, that's going to be a lower number. The closer you are to 0, that's going to be a higher number when you're in the negatives. So in fact, negative 25 is greater than negative 50. That's a change. So that means that this is the first time we're seeing that our inequality reverses. Now if we divide by positive 5, we will have 1 and 2. Well, 1 is less than 2. So from the original inequality, it was preserved. If you divide by negative 5, you'll have negative 1 compared to negative 2. Negative 1 is to the right or above negative 2. So in fact, negative 1 is greater than negative 2. And once again, we have a reversal of our inequality. So looking at these and beginning to generalize, we're noticing that the things that reverse are the things that involve multiplication or division by a negative number. So when you multiply or divide by a negative, the inequality flips or reverses. Interesting. So let's see how we can apply that to the inequalities that we've been solving. I took 2 inequalities that you solved on Tuesday, and you found the solutions to those by testing possible solutions. So we know that both of these work. We had 6x plus 10 is greater than or equal to 22, and we have minus 6x plus 10 is greater than or equal to 22. So in this one, if we wanted to solve this, what the person had done, and we were examining kind of a student's work here, they had subtracted 10 from both sides. They got that 6x was greater than or equal to 20 to 12. Then they divided both sides by 6, and they got that x was greater than or equal to 2. And they tested, and it was greater. Over here, we started in a similar fashion. We had minus 6x is greater than or equal to 12. Then we divided by negative 6. We got that x was related to negative 2. And after testing both sides, and you can go back to last Tuesday's video to look at that, in fact, x was less than or equal to negative 2. So comparing these two, if we wanted to check specifically the symbols, because that tells us what direction our solution set is going to go into. Let me grab a different color marker. We notice that in this case, the inequality was preserved throughout. It was always x is greater than something. In this case, the inequality changed. It went from being greater than to being less than. So it flipped. The question is, what was different? What caused it to flip here where it did not flip here? The only thing that was different was that we had this negative number. So we were dividing by a negative 6 instead of dividing by a positive 6. So to go back to that generalization from the first problem, where we only had numbers, no variables, it looks once again like if you multiply or divide by a negative number, your inequality is going to flip. And that is a property of inequalities that feels strange if you're just trying to solve it straight down. But when you test the solutions, you see that in fact, because you're now dealing with kind of negatives of each other, what was greater is now less than. Like 50 is greater than 25 on the number line. And I can actually do that. On a number line, if you had 0, 25, 50, we see that 50 is greater than 25. But if we're in the negatives, and we were at 0, negative 25, negative 50, negative 50 would be less than negative 25. And once again, the inequality is flipping. And it has to do with this flipping around 0. It changes what's going to be less and what's going to be greater. That was the big takeaway from today, from yesterday. And that's what students are going to need to use as they are solving their inequalities over the weekend. Otherwise, they're going to be doing a lot of testing of possible solutions, or they might be assuming that the inequality is actually going, the solution set goes in one direction when it is not. We looked at one more thing though. I'm just going to hold these up. Looking at the one on the left, we tried to determine, can you tell right away whether the solution set is going to preserve or reverse the inequality? And people said, that's a negative 2 that we're going to multiply and divide by, so this one is going to reverse. Over here, there is no negative number that you are multiplying or dividing by, so this is going to be preserved. So our inequality symbol would flip here, and it would not flip here. Let me know over the weekend if you have any questions. We are going to get a chance to practice with this more on Monday, because I know that this still feels kind of fresh. Have a great weekend.